I came across this problem in an old book on number theory. Find an infinite arithmetic progression for which no term can be written as the sum or difference of two primes. Let our arithmetic progression be written as an plus b, where a and b are integers and n is the natural numbers. We want to find a and b that satisfy the condition stated in the problem. Let's try and find some properties of the sequence to make our search a little bit easier. Let x be a term of our sequence. If x is even, since most primes are odd, there would be so many possibilities to check, and that would make our task unbelievably difficult. On the other hand, if x is odd, it has to be written as the difference of an even and an odd prime for it not to satisfy the condition, meaning 2 has to be one of the two primes. This makes our task much easier, so let's look for a sequence of only odd numbers. This means that b is odd and a is even to ensure that s contains only odd numbers. Now we want to make sure that an plus b can't be written as p plus 2 or p minus 2 for some prime p. To do this, we want an plus b plus 2 and an plus b minus 2 to be composite for all n. We can accomplish this by writing the greatest common divisor of a and b plus 2 and ensuring that's greater than 1, and doing similarly for the greatest common divisor of a and b minus 2. Since then, an plus b plus 2 and an plus b minus 2 could be factored, and therefore wouldn't be prime. Using these constraints, we can find a and b to construct our sequence. If b equals 3, then b minus 2 equals 1, and we can't use these greatest common divisor constraints, so b equals 5 happens to work. We would then need the greatest common divisor of a and 7 to be greater than 1, and the greatest common divisor of a and 3 to be greater than 1, and a equals 42. Works for that, remembering that a has to be even. So our sequence is therefore 42n plus 5, for n representing the natural numbers. To check our work, we can look at the first couple of terms to verify that the desired property is satisfied, and we can also reverse our construction to create a proof showing that all the terms of the sequence satisfy the desired property as well.